I welcome you all to BIM Karambe Africa 2020, and I trust you're having a great time out through the conference, and I believe you're excited to be here as I am. I would love to thank BIM Karambe for the opportunity to present my topic to you. Of course, the main motive of BIM Karambe is to encourage BIM participation across Africa, all because innovation matters. I present to get started with AEC Automation, Computational BIM and Beyond. My name is Ibrahim Shittu. A little bit about myself. I'm a civil engineering student at the University of Ilorin, Nigeria, and advocate at BIM Africa. I'm an Autodesk ambassador. I love to explore the use of BIM and its integration with innovative technologies to my AEC workflows. I'm also enthusiastic about providing long-lasting solutions to the AEC industry to achieve goals and objectives while pushing beyond societal norms. So, this is session summary. This learning session will take you through how innovative technology are improving AEC workflows to achieve much more effective and efficient results, and also provide long-lasting sustainable solutions for the AEC industry. This session will not only take you through automating your workflows and the future of work, but aims to spark your creativity and enthusiasm towards implementing all which you'll be learning in this session and providing long-lasting solutions to the AEC industry. It is required for you to have prior knowledge of BIM and its tools, but if you don't, you still have a lot to learn out in this session. This session aims to provide a clear starting point as well as case studies of ways you can enhance your design workflows. The learning journey never truly ends for us. Without further ado, let's begin. So what are learning objectives for this session? This session is divided into three parts. The first being automation, the future of work. We will discuss what is AEC automation, why you should automate your workflows, then AEC automation, any difference. The second being technology, various programs or software used in the AEC industry. We'll discuss computational design, where we discuss Revit, Dynamo, BIM, and Grasshopper 3D. We'll move on to discuss Revit macros, then other AEC automation tools. We'll discuss visual programming or traditional coding. Then the third being a case study where we learn to automate tasks using visual programming tools. We'll create complex geometry. Then we access data using the Revit API, Dynamo, and Python. Then we also discuss artificial intelligence or machine learning in the AEC industry, particularly generative design. So, automation, the future of work. I would love to start with a bit of motivation from Steve Jobs, where he says, only those who think they are crazy enough to change the world are those that usually do. So, we know what automation is, and it's particularly application of technologies to improve your workflows to provide much more effective and efficient results. But I believe AEC automation is much more spectacular than just automation. So AEC automation, what is AEC automation? Of course, taking things that took months to be done in days and that which took days to be done in minutes or seconds. But let's take a look deeply into AEC automation. Bill Allen once said, "We will see much more done by computers and machines that we have never seen. Rather than building information modeling, we would have building information optimization. Rather than manually drawing walls, doors, and columns for what we think is a good design, we will feed the computer rules instructing to give us a building's optimal footprint, structural load capacity, thermal performance, among many others. Things that took months will be done in a day." So the big question is, what does that mean for you as a professional, and how do you play part in this changing process? It's quite a big one, and it's evident that it's either you learn to upskill or you become irrelevant over the coming years. So let's take a look at this graph right now, and I believe so many of us are familiar with this graph, and it just shows how technologies have come to influence the AEC industry over years. So we began from 1950s where we had Androids, and we moved on to the 70s where we had CAD, then parametrism in 2000s, then we had BIM being introduced in the AEC industry, then we have algorithmic modeling, then we have interoperability, photogrammetry, AI BIM, generative design, robotic construction, and Internet of Things, among many others coming to the AEC industry. So, and it's quite evident that between the 50s and the 2000s, the AEC industry was very slow to implementing all these technologies into their workflows. And over decades, we've always outsourced our IT problems to either programmers or large IT firms to provide solutions for us. And moving on to the 2010 to 2020, we had an upward surge where so many technologies were introduced to the AEC industry till now, and I believe many more are coming to the AEC industry. So the world is going digital in a way where we have architects providing tools for architects, and we have civil engineers or quantity surveyors providing tools for themselves. So going back to the big question is, what does this mean for you as a professional, and how do you play part in this changing process? As earlier said, the world is quite evolving very fast, and it's either you learn to upskill or you become quite very much irrelevant. So in the coming slide, we will discuss AEC automation and how for you to implement all these technologies into your workflows and providing long-lasting solutions for the AEC industry. So why AEC automation? Of course, we want to quit our boring tasks and automate our workflows, but I believe there's much more to AEC automation than just automating your workflows. So let's discuss AEC automation first. And when we discuss AEC automation, we can never neglect two terms, which are quality and time. So when we discuss quality and time, we always think when we try to automate our workflows, we are having a lesser quality, being the fact that we spend much more time on our projects. Or sorry, we tend to spend lesser time on our projects, which is wrong. AEC automation provides you the ability to get much more better quality for your project and in lesser or shorter time. So taking it that is at the two graphs below, we have three projects. On the left being without automation and the right being with automation. On the left, we have a base level of quality from automation and standardization, which is that BIM. And on the right, we had a reduced plenty of the mission returns and shortened project completion time frames. That is with automation. So it's quite evident that the all three projects took the whole time frame, and of course, that doesn't guarantee much better quality for your project or a better result quality. But take a look at the right hand side. We had a shorter time for project 1, very short, a lesser shorter time for project 2, then let's say a bit shorter time which was saved from project 3. So at least all in we have saved at least 40% time, and of course a higher quality for our project. So taking a look further, so we have a bar where the first being no automation being design process and second being with automation being design process. So from preliminary BIM modeling to detailed BIM modeling to information management to documentation, just imagine how much time was spent all from just automating your workflows. Of course, the reasons for automating your workflows are many, and this is just with regards to quality and time. So when we discuss automation, you take a look at documentation. Many of us tend to employ BIM, but we don't take full advantage of BIM. Just like the automation goes, and we employ automation, but neither do we take full advantage of automation in AEC space. So if you take a look at documentation, I would say a lot of us try to do what we involve ourselves in what is called either I would say Revit management, not actually BIM management, because we say we employ BIM in Africa, but we go through manual design processes and manual documentation processes. So let's move on to why we automate our workflow aside just quality and time. So of course, a great way to upskill, to standardize your projects, to improve accuracy, eliminate tricks and redundancies, parameterization, easier collaboration, for you to increase speed, efficiency, and productivity, among many others. So these are just few reasons aside quitting the boring tasks to why you can automate your workflows. Imagine it's of course a great way to upskill for you to become irrelevant to the AEC industry over time, to create standards for your projects, to improve accuracy, eliminate risks of human errors and redundancies. Parameterization being the fact that you have to create so many solutions depending on the parameters or input sets. Easier collaboration, increasing in speed, efficiency, and productivity. So let's move on to AEC automation. Any difference? So what makes the AEC industry spectacular, and why is AEC automation much more better than just bare automation? So the AEC automation tends to combine various industries to form what is called the AEC industry. So where we have the freedom of implementing various technologies to our AEC space, ranging from BIM to digital twins to IoT, AI, ML, VR, AR, robotics, among many others. All these which form to be what is called the AEC automation. Just imagine the freedom we have to provide much more effective and efficient results. And it's quite evident that African economy is quite slow to implementing technologies, which I believe is a much more reason for this topic. For you to spark your creativity and enthusiasm towards implementing what you learn in this session. So moving on to the second slide, further on we have technology in Newton. Iron once said the master builder will be a machine, which is very true. So we have various AEC programs ranging from data capture to data management to IO, to design authoring to collaboration, fabrication, environmental analysis, VR, clash detection, conceptual modeling, among many others. But our focus will be parametric modeling, where we'll discuss tools like Grasshopper, Python, Dynamo, Rhino, among many others. So computational design, what is computational design? So I would love to define what design is actually. So when we see design, design is basically taken from different stages ranging from strategic definition to in use, where we have different stages coming between them for you to understand your stakeholder values, generating ideas, deciding on core design principles, dealing with change, monitoring, review, knowledge capture, construction, documentation, calculation analysis, calculation plans, among many others. Then move from strategic definition to preparation and brief, concept design, develop design, technical design, construction, handover, in use. Just imagine having to deal with change all through these stages. And that's what does that mean for you, and that's the flexibility of computational design for you. So what is computational design? Our basically design computational design is a change in the medium of design experience from geometry to logic. Rather than you going through manual processes, it's just for you to feed the computer rules, then for you to get your results based on the inputs or inputs or parameters set to you for the computer. So we have computational design tools for BIM, being one being Dynamo, which is created by Autodesk team, and second, the most popular, which is second being Grasshopper, created by Robert Martin and Associates. These are the two most popular tools for computational BIM or computational design in the AEC space. So moving on, so let's talk about Dynamo for Revit. It's of course a gateway to parameterization. And where can you find Dynamo? It's either you get Dynamo from within Revit, or you download Dynamo as a sandbox, just a standalone actually, and you can get that from dynamobim.org or via the Autodesk platforms. So where can you find Dynamo for Revit within Revit? So you can find under the manage ribbon, where you have Dynamo and Dynamo Player. So the player allows you to run scripts without you opening Dynamo itself. And this is how the interface of Dynamo looks like. So how does Dynamo look like? We have the ribbon, we have the search button where you can get access to various nodes. Our Dynamo just made of nodes and strings, and it's very easy to use, and it takes no time for you before you learn to create complex scripts or provide complex solutions. We have the run button where you can either be in manual automatic mode, and also Dynamo allows you to run Python scripts within the environment. We also have the 3D geometry preview, which allows you to change between either scripts or geometry itself. So as earlier said, we have the ribbon, we have the add-ons where you can either install packages from within Dynamo itself or dynamo.org, among many others. So how does Dynamo interact with Revit? I will just say this is my little explanation to how Dynamo interacts with Revit and how Revit interacts with Dynamo. As Dynamo goes from interacting with the Revit API to Revit, then it's a cyclic process, and either Dynamo interacts with player and or with Python itself. So it's just a simple interaction to see how Dynamo interacts with Revit and how you are able to access data via the Revit API using Dynamo and or Python. So where to start with Dynamo? Of course, I'll say the best place to start with Dynamo is through the primer, which can which you can access via primer.dynamo.org. And I would say it's like a Bible for Dynamo where you can get everything you need to know with regards to Dynamo as a beginner. And I'm very assuring that once you go through the primer, you'll never be disappointed, as you find everything you need to know with regards to computational BIM or computational design, and how you can begin from creating simple workflows to creating complex workflows for the AEC industry. So moving on, and also you can start with Dynamo via Dynamo forum, where you can meet the various professionals and discuss with them. So I advise for you not to just begin and dive into the Dynamo from then expecting solutions to your problems. It's an advice for you to dig into your problems, try to view what you're facing, then try to provide solutions yourself before going to the Dynamo. You might be lucky to find problems to your solutions, and you might not be lucky. So other learning resources include YouTube, Autodesk University, and Think Parametric. Think Parametric. There are so many YouTube channels which you can learn from, like the Revit Key, also being good, Revit Key, Melinda Carr, among many others. There are so many speakers that present topics with regards to Dynamo computational design on the Autodesk University platform. And Think Parametric provides you with various courses to which you can get started with computational BIM for with computational design for BIM or computational or Dynamo. So computational BIM. Let's talk about Grasshopper 3D. So it's quite great that you can now access Rhino inside Revit via Rhino Inside. Usually, platform allows you to access both Rhino and Grasshopper. That's the computational design tool for Revit for Rhino within Revit itself. So how does Rhino Inside looks like? Let's take a look. So we can access Rhino via after installing the add-on. You can access it via the Rhinoceros tab, and this is how it looks like. You can access both Rhino, Grasshopper within Revit to automate your tasks. And just imagine the power of you having both Dynamo and Rhino just in one software. Imagine the power you have. So how does Rhino interact with Revit? I would say it's either Rhino interacts directly with Revit or via IFC file format, and Rhino can also interact within itself via Python script or C Sharp. Also, just like how Dynamo trying to interact with Python itself to access the Revit API, you can also do that within Grasshopper via Python or C Sharp. So we're going to start with Grasshopper 3D. So I'll recommend you to start with Grasshopper via the tutorials page on their website. There are various tutorials for you to go through and for you to get, of course, the basic understanding of Grasshopper. But I also suggest you have at least prior knowledge or know the essentials of Rhino before moving into Grasshopper. And just like for you to have big knowledge of Revit before diving into Dynamo, it's required for you to have prior knowledge of Rhino before diving into Grasshopper also. And of course, just like Dynamo forum, you have the Grasshopper forum or Rhino forum, where you can meet the various professionals with regards to Rhino and Grasshopper, or you can ask questions, or you might be able to find solutions to your problems also. Likewise, Dynamo forum. So other learning resources, you have YouTube, Think Parametric, and ModeLab. ModeLab has they've created the Grasshopper primer. It's very thorough and a great starting point for you to dive into Grasshopper 3D and begin computational design. So Revit macros, what are Revit macros actually? I would say Revit macros are user created commands created in the Revit API and created in Sharp developed and open source IDE, which is integrated into Revit. So what is Revit macros? And I believe it's just a plain definition, and let's see what Revit macros does for you within Revit. So where can you find macros? You can find under the manage ribbon where you have the macros manager, and once you click on the macros manager, you have something like this. Macros is very great because you have the ability of you coding in various languages such as C Sharp, VB.NET, Ruby, and Python. The macro manager allows you to create, run, edit, and delete macros. Imagine the flexibility you have with macros, just the power of the AEC industry. So how does Sharp develop look like? So basically, this is how Sharp develop, and this is a Python script which automates your tasks within Sharp develop. So once you've coded in Sharp, you can either run within the IDE or run with the macro manager, and it's quite easy. So I'll say the step for you to dive into macros or traditional coding is for you to begin with either Revit, Grasshopper, Revit or Rhino. Then you move on to Dynamo or Grasshopper. Then you move on to Python within Dynamo or Python or C Sharp within Grasshopper. Then for you to move on to either you coding macros or creating plugins for yourself or for the AEC industry in general. So other tools include, we have Pirate by Isan Iranijad. This is a very good free and open source tool by very great tool by Isan, and it has been great source of help for the AEC industry over years right now. And what does Pirate do for you? It adds a powerful set of tools to Revit workflows. It helps you sketch out automation ideas quickly in Revit. You can write your own add-ons for Revit using Python, C Sharp, or VB.NET. Distribute your tools, either Revit, Dynamo, or Grasshopper, with your teams using a unified interface, and share your tools with the community, of course. So another platform I'd like to say is The Roots by Jose. The developer provides tools like Family Revisor, SheetLink, Paramanager, OneFilter, ProSheets, TableGen, SheetGen, Reordering, among many others. It's quite great that they've been able to provide this for the AEC industry, and they've made a promise that whatever is free now will continue to be free. And that's a very great news for the AEC industry, and kudos to the team from The Roots. So visual programming or traditional coding. So let's begin with visual programming. Visual programming is open source, free and easy to use. You can make it to profit from either sharing your script with the community. I'll say it's tied to Revit, and they have a strong community where you can learn from and interact with. They're an AEC market disruptor and support coding, which is a very great news. So traditional coding. So They are produced using the Revit API. They have a very great speed, an optimal speed. It's challenging to learn, and it's possible for you to make profits. It's the flexibility varies among many others. So before we discuss move on to the case study, I would love to give an advice depending on where you are coming from, either from a background with a computer programming background or from just a background without computer programming. So for you coming with a programming background, I would advise for you to also learn visual programming tools such as Dynamo and Grasshopper 3D, and learn the basics of AEC Industry and AEC Automation. Before moving on to creating plugins or add-ins for yourself or for the AEC community. And for you coming with from a background with no a background with no coding experience, so it's quite easy for you because you have various tools to learn from like Dynamo and Grasshopper 3D, and a strong community to learn from, and it's disrupting the AEC industry currently. So moving on to the case studies, and I would say be passionately curious and learn to feed your curiosity. So this is a basic script where we created multiple sheets with views in Revit, and just with a couple of nodes and strings, we're able to create this script. And the great part about Dynamo script is that it can be reused in various other projects, ranging from the use case and the complexity of the script. Just imagine how fast we're able to create various scripts within Dynamo, just with a few strings and nodes. So other suggestions for you include flipping grid heads, changing test case, renumbering elements, batch insert families, add revisions to multiple sheets, among many others. I would love to say the limits. There's no limit to which you can do to what you can do within Dynamo. Dynamo is limited based on um, your knowledge, and whatever you can do within Revit, you can do within Dynamo. And thanks to Python within Dynamo, you're able to extend the usability of Dynamo and access the Revit API directly to provide solutions to problems you are facing. So moving on, we're able to create complex geometry within Dynamo just with a couple of strings and nodes. And just imagine you creating geometry like this within Revit itself, and the amount of time you spend creating geometry like this, and just in a few seconds you run the script and you've had your result. And of course the script can be used in various projects, all depending on the complexity of your script and how you create your script for and the use case. So also with Dynamo and Python, you can access the Revit API to get data from Revit and interact with the back end of the back end data from Revit. Or with a few lines of code, you're able to create scripts and just access backend data within Revit, within Dynamo itself. So in this script, I was able to generate all doors from this project, and from the script we have 8 doors, and that was I was able to get within Dynamo itself. So moving on, we're able to use Dynamo or either Grasshopper to test performance using Karambe 3D, a parametric engineering tool, which is a case study we are taking here. So with Karambe, we are able to attain parametric setups, and provide structural loading capacity, structural loading analysis, and among many others. Optimization, generate algorithms and optimization. So other structural analysis tools include Kangaroo, Human and Booleans, which are all within Grasshopper tool. Other test performance tools include Ladybug, Honeybee, Butterfly, Gecko, Heliotrope Solar, Dragonfly for environmental or for environmental analysis. So just within Dynamo, we're able to obtain solar analysis, sun analysis, and comfort analysis among many others. So generative design. Generative design is an iterative process which quickly provides design alternatives based on goals, constraints, and inputs we give to give you higher performing options for data-driven decision making. So in this definition, we are trying to understand basic concepts. One being iterative process, also quickly provide design alternative based on goals, constraints, and inputs to give you higher performing options for data-driven decision making. So how does generative design work? Well, of course, you generate, then you analyze, then you rank, evolve, explore, integrate. It's all a cycle process, and so you have to generate your results based on various parameters you set, analyze them, rank them based on your needs, evolve, you could change them, or if they suit your need, try to explore various other options, then integrate them into your workflows if you so wish. And this is just a simple generative design process which shows how it works and how you have to generate various options within seconds. So this is a script by Ozibimbu where he was able to compare two the same script within Grasshopper and Dynamo. The left being using refinery in Revit and the right being from Galapagos in Rhino inside. He was able to generate at least 150 results within seconds, and imagine the speed of refinery being able to create results, a random result based on your parameter set, your input or your constraints. And you're able to explore from at least so many results with regards to your needs and be able to integrate them into your workflows. Let's take a look at how you can do the same within Rhino Insight. It's quite evident that Rhino Insight Galapagos is a bit faster, and over time it tends to create a much more quality result over time. The more you run the script, the more you get much more better results with regards to your parameter sets, input, goals or constraints. Just imagine the power you have implementing these two powerful programs into one software and being able to provide solutions to problems in the AEC industry. So thank you, Osim Guru, for this awesome presentation, awesome guide with regards to refinery and Galapagos. So other creative design tools within Rhino includes Colors among others. So what is my conclusion? I'll say the future of BIM might not be BIM, and be prepared is coming faster than you think. I'll also say a very big thank you for you to stay this long, and I believe you've learned a lot from this session and enjoy the rest of the conference. Thank you.